Hello and welcome to this video on finding the perimeter of sectors. So we've got 4 questions here today, and I would recommend you pause the video and attempt each of these questions before we go on. And let's check it out. Find the perimeter of this shape. Okay, so when I see the word perimeter, I think walking around the outside of the shape, adding as we go. All right, so looking at this, the perimeter is the curved part. I've got to walk around that curved part, plus the 2 straight bits, right? So plus this, plus this. So I'm just going to say plus the 2 straight parts. Okay. Now, what will that curved bit be? How could we find the perimeter of that curved bit? Well, if we notice, this is a full circle. So what is the perimeter of a full circle? Well, we've got our little formula sheet down here. The perimeter is also called the circumference of a circle. So of a full circle, it's 2 pi r. That's the perimeter of a full circle. But we only want a part circle. So we need to put this factor out the front, right? This factor, theta on 360 times 2 pi r. And the theta has to be this angle inside the circle. So a sector is a fraction of a full circle. And then you're just adding on these 2 straight lines here. So this fraction comes from the fact that there's 360 degrees in a full circle, and the fraction is the number of parts over the whole. I hope that makes sense. So that's that bit. Then we've got the 2 straight parts. Now, what are the 2 straight parts? Right? That is the radius. That's the radius. That straight part is called a radius. So this is how they derive that formula. So the perimeter of, what happened there? The perimeter of a sector, or otherwise called a part circle, is this formula. Okay, so then we just substitute in. We got 30 over 360 times 2 pi. And we know the radius is 2. The radius is the half the distance across the circle. And then we've got our 2 straight bits, so 2 times r. And if we come over here, we can do that. So you might want to simplify it a little bit before you put it in your calculator. But I'm just going to check it in my calculator for time's sake. So 30 divided 360 times 2 pi times 2 plus 2 times 2, which is 4. So the perimeter of this sector ends up being, to 2 decimal places, 5.05. And if we think about the perimeter, the units should be meters. It's a distance. You're walking around the outside of this little pizza piece. Oops. Okay. Now let's check out this. Find the perimeter of this shape. And so I realize, okay, this is part of a circle. This is a fraction of the perimeter of a full circle, otherwise called the circumference. All right. Now that covers the curved bit. So perimeter equals curved plus the 2 straight bits. You can write a wordy formula like that as your plan. So the curved part, fraction of a circle, and the 2 straight bits, well, that's the radius. So that's a radius, that's a radius. So 2r. And then we substitute in. So this theta is the angle inside the sector. So let's substitute. Times 2 pi times r is 4.5 plus 2 times 4.5, since there's 2 radiuses to walk around. And then straight into my calculator. Times 2 pi times 4.5 plus 2 Plus, well, I know that 2 times 4.5 is 9. 21.57, if I'm doing correct, 2 decimal places. And perimeter, well, we were given in centimeters. So we have to answer in centimeters. Okay. Now, find the perimeter of this sector. All right, so I'm walking around the outside of the shape. So I know that the full perimeter is the curved bit plus the 2 straight bits. Plus these guys, right? Now the curved bit, that is a fraction, the number of parts over total, times a fraction of a full circle's perimeter or circumference. And the 2 straight bits, well, I know that's R and that's R. So that's 2R. Now here, this is important to recognize. Notice in these ones, we were given the angle inside of the sector. But this one, we're given the angle outside. So I would label up my diagram, make sure that you have that angle inside the sector. If you use that angle outside, you would actually be finding the perimeter of this sector here, if you can see that, which is not what we want. We want that bit. Okay, so what would that bit be? Well, we know that there is, in a full circle, there's 360 degrees. And we're given the outer bit, which is 120. So let's actually see this. So full circle, 360. But we just want this bit here. So 360 take 120. We're going to subtract because we're getting what's left over. All right, full is 360. Yep, I think you get the picture. 360 take 120, 240. So sometimes you actually have to calculate theta. Make sure that you plug that into the equation and not the other one. So 240 on 360 times 2 pi times the radius was 10 plus 2 times the radius, which is 10. And then just straight in your calculator, times 2 pi times 10 plus 20, because 2 times 10 is 20, 61.89. And then the units we check at the end, we plugged in centimeters. It's a distance around the outside, so she gets centimeters out. And last question for today, finding the perimeter of this shape. So it's perimeter of a sector, which we know is the curved plus the 2 straight bits. And I just write it down every single time. Perimeter equals curved part plus 2 straight bits. The curved part, well, that is a fraction, number of parts over the total, a fraction of the perimeter of the full circle. And the perimeter of the full circle is 2 pi r. The 2 straight bits, well, that's 2 of the radius. Now, when I come over here, I know that I want this, I need this sector, I need to have this angle inside the sector. I'm given the angle outside the sector. Now, looking at that, I know that that's a right angle. That's the symbol for right angle, so I can label that 90 degrees. Now, if in a full circle there's 360 and we're given the outside is 90, then what's left will be 360 take 90. So sometimes we've got to calculate theta. It must be that angle inside, 360 take 90, 270 degrees. Now make sure you substitute that 270 into your equation. Times 2 pi times 3 plus 2 times 3, which is the radius, good, into our calculator. Times 2 pi times 3 plus 2 times 3. 5,095.38, and we substitute in, we substituted in meters, so we should get out meters. So that's how they find the perimeter of a sector. So I guess the takeaway is theta must be angle inside sector. And then what's our other takeaway? We can say perimeter of sector equals curved, which is a fraction of full circle perimeter, plus the 2 straight bits, which is 2r. Fraction means number of parts over the total. Of means times. Full circle perimeter, well, that's circumference. And yeah, I think in an earlier video I showed you area of a sector, which is actually much simpler. And I might just quickly show you area of a sector. You know what? I'm not going to show you. Go back and watch the video on area of sector. And I will see you in the next video. Bye-bye.